Okay, today we're going to talk about permutations, and more than likely this is something that you haven't heard before, haven't encountered, at least the vocabulary word. You've probably tried to attempt problems like this before, but not necessarily known the equation to do it, and so that's what we're going to learn today, is kind of exactly how to solve these, the system to use, and I think it's really cool. So, a permutation, it says sometimes the order of objects in an arrangement is important. And a permutation is an arrangement of a set of objects in a particular order. So let's look at this first example. It says our class is going to participate in a contest, and we're going to pick a first, a second, and a third, just first and second place winner, sorry. How many choices do we have for someone in first place? Okay, so we're obviously not in school. So here's our class. Okay, I've created our own little class. Here we go. Okay, so for today, I'll put them all up here. This is our class. So if I'm going to award a first and second place winner, how many choices do I have for somebody to be in first place? There's 1, 2, 3, 4, 5, 6, 7, 8 people. Okay, so I have 8 choices for my first place winner. Then it says, once we pick our first place winner, how many choices do we have for the second place? Okay, so this guy is first. So now, how many people are left who could go in second place? 7. Okay, and it's this girl. She gets second place. I don't know what she is. Like a queen? I don't know. Okay, so it says using the counting principle. Okay, the counting principle just says that when you're making choices, you can multiply them together. So like if you had 2 pairs of pants and 3 shirts, you could make 6 outfits. Okay, so using the counting principle, find the number of ways to choose 2 students from our class. So if I have 8 people who could go first, and then that leaves 7 people who could be in second place, 8 times 7 is 56. So out of this class of 8, there are 56 different ways that I could pick my group, or not my group, sorry, I could pick first and second place, right? It could be this guy and this guy, which would be different than this, because this would be first, second, this would be first, second. So the order is important, okay? So that's how we do those. So let's look at this part. It says write a rule for determining the number of choices for first and second places of any size class. Okay, so what if we had 100 kids? There would be 100 people who could go in first and then 99 people who could be second. So we do 100 times 99, right? What if there were 10 people? There would be 10 people who could come first and 9 people who could come second. So look at the pattern that's happening. If I have n number of students, okay, then my second place would be n minus 1, right? 10, 9, 199, 1,999. Okay, and we could keep going for third place, fourth place, fifth place, on and on. So the next question says, in a school track meet, the 6 runners in the 200-meter dash line up in lanes 1 through 6. Those in the middle lanes have an advantage. So the order of the runners matters. Okay, that means it's a permutation. How many ways can we line up the 6 runners for the track meet? Okay, so how many, I'll use my little people again. Okay, these people are running in a track meet. How many choices, if I'm picking someone to go in lane number 1, how many choices are there? 6. Okay, this guy's in lane number 1. So how many people are left who could go in lane number 2? There's 5. This girl goes next. How many choices for lane 3? 4. Now there's 3. You guys see what's happening. Then 2, then 1. Okay, we can use a calculator on this. So I'm going to do 6 times 5 times 4 times 3 times 2. And that gave me 720. Isn't that crazy that just for these 6 people, there are 720 ways I could line them up. Okay, at a school awards ceremony, the principal will present awards to 7 students. So let's just say it's these 6 plus her. Okay, there's 7 of them. How many different ways can the principal give out the awards? Okay, so there's 7 people who could go first, right? And then there's 6, and then there would be 5, and you would go all the way down. And when we multiply that out, we would get 5,040. So what we just did, the last 2 problems, was called a factorial. That's where I am starting on a number and multiplying all the way down. Okay, the product of all integers less than or equal to a number is a factorial. So like what I just did up here, this one is 7 factorial. This problem right here is 6 factorial. So let's look up here. It says you have 9 songs on your homework playlist. How many different orders can the 9 songs be played? So you have your 9 songs, you hit shuffle on your playlist, right? How many possible orders could there be? Well, there's 9 choices for the first, 8 for the second, 7, 6, 5, 4, 3, 2, and 1. So I'm going to start with 9. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Okay, and I don't really have to do times 1. So just with 9 songs, there are 362,880 ways that I could arrange those songs. Okay, so why don't you pause for a second and try to do these 2, and then hit unpause, play, hit play, and check your answers. Okay, so 4 factorial, 4 times 3 times 2 times 1 is 24. And then 5 factorial, 5 times 4 times 3 times 2 times 1. You should have got 120. Okay, but sometimes what's going to happen is you're not going to necessarily be arranging all the people. Okay, sometimes you might just be picking 1 or 2 out of the group. So, for example, a class of 25 students must choose a president and a vice president. Okay, so we're gonna pretend I have 25 of these. I could probably go upstairs and find 25, but you get the idea. Okay, so we're saying this is 25, but I'm only gonna pick a president and a vice president. So I'm trying to figure out, well, how many ways could I pick a president and a vice president? So I have 25 choices for the president. Okay, I pick him. Now there's 24, and it's this guy. So, president, vice president. Do I need to do any more multiplication? No, because I'm only picking 2 positions. So this, we're going to use what's called permutation notation. I know it's a little bit small here to see, where it's N, P, R. And it just means this is how many objects you have total, and you're picking them R at a time. So I had 25 people, and I'm only arranging 2 of them. So like on this one, okay, it's 15P3. So I have 15 people who could go first, then 14, then 13, right? And I'm stopping there because that's 1, 2, 3 choices. So I'm gonna type into my calculator 15 times 14 times 13, and I get 2,730. That would be my answer. Okay, 10P4. I'm going to start on 10, and I'm only making 4 choices. So 10 times 9 times 8 times 7, because that's 1, 2, 3, 4. 10 times 9 times 8 times 7. So that gives me 5,040. Okay, so why don't you pause it and do 12P2 and 9P3, and then we'll talk about it. Okay, for 12P2, you should have got 132 because you're starting on 12 and you're making 2 choices. And then on 9P3, you're starting on 9 and you're making 3. 1, 2, 3. So that's 504. So let's look at it in terms of a word problem. Every day, oh, this is funny. This was a joke from several years ago. Okay, Judson does not go through 2 girlfriends a day, but every day Judson goes through 2 girlfriends, one in the morning and one in the afternoon. There are 15 girls in the class. How many different pairs of girlfriends could he have? Okay, so there's 15 to pick from, and he's picking 2. Okay, and saying girl in the pink shirt, and where did that other girl go? And this looks like mail delivery girl, right, is different because this would be morning and afternoon, and that's different than this because this would be morning and afternoon. Okay, we're in middle school. We're not promoting having a girlfriend. This is just supposed to be funny and memorable. Okay, so 15P2 means he has 15 choices for the first girl, 14 for the second. 15 times 14 is 210. Okay, at a track meet, 20 students entered the 100-meter race. And how many ways can first, second, and third places be awarded? So there's 20 kids running, right? And we're only figuring out how many different orders there are for 3 of them. So as they're running, there's 20 kids who could cross the finish line first. Okay, it's me. So after I cross the finish line first, there's 19 people who could come in after me for second. Okay, and then it's, I don't know, someone else. And after they cross the finish line, then there's 18 people who could cross third. Okay, so 20 times 19 times 18 is 6,840. Okay, and then this last one. It says a certain type of lock has a 3-number combination. How many different 3-number arrangements of numbers with no repetition of the same number is possible? Okay, so look at my keyboard right here, my little keypad. Okay, how many digits are on there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Is 0 a digit? Yes, so I have 10 possible numbers. Okay, so if I have 10 possible numbers, and then my code is 3 digits, that means I'm only going to arrange 3 of them. So when I'm picking what could be the first number for my combination, I have 10 choices. Okay, I pick 7. So now, how many choices? 7 is gone. How many choices do I have for my second number? Well, there's 2, 5, 8, 9. Right? I pick 0. So now how many are there? 2, 5, 8. So 10 times 9 times 8, I think is 720. Yes, there's 720 different possible codes.